So the problem is to calculate the inverse sine of negative root 3 over 2. Okay, that's fine. What you have to keep in mind is that the range of the inverse sine is between negative pi over 2 and pi over 2. That is between here and here. So somewhere in this range is going to be your answer to the inverse sine. Now, what you're looking for when you do this is an angle whose sine, or that is whose y coordinate is negative root 3 over 2. You might want to think 5 pi over 3, but 5 pi over 3 doesn't fit in negative pi over 2 to pi over 2. It's outside of that range. So instead of doing positive, say, 300 degrees, you got to do negative 60 degrees. What I would suggest is that maybe taking your calculator, you can do this, put your calculator in degree mode because you'll actually recognize the degrees, and do the inverse sine of negative root 3 divided by 2. That gives you negative 60 degrees, and then you can convert that negative 60 degrees to negative pi over 3. There you go. That's nice and safe.
Got it. Thank you.
You're welcome. You're welcome. Okay, so let's pick it up with some thoughts from section 3.2. Kind of going along with what we just did, what if you had to find the inverse cosecant of a number like square root of 2, something up at the top? Let's work on that one. The problem that you're going to run into is that, yeah, we don't have an inverse cosecant button on our calculator. So let's start by writing it down. Inverse cosecant, cosecant inverse of, was it positive root 2 or negative? Positive. All right, so we're good. The thing to keep in mind about all your inverse sine and cosine or cosecant problems is that whenever you take the inverse trig function of a number, you're going to get an angle like that. So what do you do here? Well, it'd be nice if we could rewrite this in terms of sines or cosines. So what I'll do is I'm going to take the inverse, I'm going to take the cosecant of both sides. So, okay, here's theta, and I'll take the cosecant here and the cosecant here. So I'm taking the cosecant of both sides, and the same thing to both sides. There's no problem there. These two operations cancel each other out. So you get the square root of 2 equals a cosecant of theta. My problem all along with this has been the fact that I don't have an inverse cosecant button. So it'd be nice if I could write this in terms of sines or cosines. Can somebody remind me what the cosecant is? It's 1 over what?
Sine.
1 over sine of theta. And if I multiply both sides by sine of theta, I get square root of 2 times sine of theta equals 1. Or if I divide both sides, then I get this. Now, this has been kind of a long journey, but if I want to get theta, then I want to do this. I'll take the inverse sine of the reciprocal. So the shortcut for you, if you're stuck with something like this, is to rewrite it and say, oh, well, that's just going to be the same as the inverse sine of the reciprocal of this. So 1 over the square root of 2. And that will give you 45 degrees or pi over 4. But this much you can get off your calculator. Now, I think there was another one kind of like that on our handout. Let me see if I can't scroll up a bit. I don't know why sometimes it seems to get a little sticky on me. So to kind of practice what I just preached, let's take a look at the cotangent inverse of -1. And we'll see if we can't rewrite that the same way we did with the cosecant problem. So let me come down here. Cotangent inverse of -1. I want to do two things in order to rewrite this. I want to take the reciprocal of this function. The reciprocal of the cotangent is what?
1 over tangent.
1 over tangent. So reciprocal there would be the tangent inverse and the reciprocal of this. So the reciprocal of that is kind of tricky because
Still -1.
it's still -1. But now this is something you can put into your calculator or Desmos because they recognize the inverse tangent. Desmos might recognize the inverse cotangent, but Desmos is only going to work in radians. So to get an answer that you recognize, which should be in degrees, put your calculator in degree mode, and then work it that way. And then say, oh, okay, yeah, -45 degrees is the same thing as -pi/4. Chances are you're going to be answering in radians. So are you okay with that little tip there on the inverse cotangent and inverse cosecant?
Yeah.
All right, so it's a nice little shortcut, and I don't feel so bad because I kind of proved it, justified it. But all that I would expect of you on an exam is for you to start out here and show me that you rewrote it like that. That's what I'll be looking for. Let's try a couple more here. Let's see. Okay, so coming down, want to find the exact value for the expression of the cosine inverse of the sine of -7pi/6. So give me a second to copy that down. Cosine inverse of the sine of -7pi/6. Well, 7pi/6 is a 210-degree angle. But instead of going up positive 210 degrees, I'm going to go a negative 210 degrees. Effectively, that's going to put me right here. So at 150 degrees, and I want the sine at that point. So what's the sine of that going to be? Can someone tell me?
1 over 2.
Yeah, 1 over 2. And now it's a matter of figuring out the inverse cosine. So what coordinate do we associate with cosine? One more time. What coordinate do you associate with the cosine function? The x coordinate or the y? The x coordinate. So I want an x coordinate that's 1/2. So my choices are here and here. Well, why wouldn't I pick this one down here? I mean, it's got an x coordinate 1/2. Nothing wrong with the cosine of 300. That gives you 1/2. But that's not going to give you the right answer on my lab math. Why do I have to pick this one?
Because the range.
Because it's not between 0 and pi.
Yeah, the range here has to be between 0 and pi. So if I'm looking for something in the range of angles between 0 and pi that has an x coordinate of 1/2. And that angle is pi/3.
Wait, where did you get that 1/2 from? The cos inverse is 1/2.
Good question. I got that angle from, or that the value from the sine of 7pi/6. So this whole thing turned into 1/2. And that's because -7pi/6 puts you right here on the unit circle. And the y coordinate there, which is your sine, the y coordinate is 1/2. So that's where I got the 1/2.
Okay, thank you.
You're welcome. Thank you. Are you comfortable with that? And this is kind of what I'd like to see from you on your exam. When you write your notes for me so that I can look at them after you take the exam, this is roughly what I'd like to see.
On
Okay.
your exam, can we use our unit circles, or would you prefer us to write them out ourselves?
Let me finish this and I'll talk to you about what I expect on the exam.
Okay, thank you.
Thank you. But I'm not going to short you on that. I'll definitely discuss that. Let's do two last problems. They're going to involve a function and a function inverse. So I'll start out with the secant of the cosine inverse of negative root 2 over 2. And again, I'm showing you exactly what I'd like on your exam. If somebody has a different method that you like, tell me now so that I know what to expect it. But I'll get uncomfortable if I see you guys doing something kind of outside the box here on this one. Okay, so I'll start out here. Whenever you take the inverse trig function of a number, you're going to get an angle. So what this is saying essentially is that the cosine of this angle has to give me this. In other words, I can write this inner parenthesis as cosine of theta equals negative root 2 over 2. Okay. Now, I've got to draw my angle here in one of these two quadrants. Which quadrant should I draw it in if the cosine of theta is negative root 2 over 2?
Second?
Second quadrant, yeah. What's that little buzzword that you guys, or that phrase that you guys use to help remember what's positive where?
All students take calculus.
Yeah, oh, I love that. You go, Drade. Well done. All
Thank you.
calculus. So cosine is going to be negative here. So that's what we got. Place where the cosine is negative. Now, there was another little acronym that you learned that you'll remember long after you've forgotten its meaning. It's Sohcahtoa, right? Sohcahtoa. Sohcahtoa stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Certainly, I'm not the first instructor in the history of math to use this, but it tells me how to draw a triangle here. Tangent is adjacent over hypotenuse. So I want to draw an angle in the fourth quadrant that has these properties. All right, so let me do that. So negative root 2 over 2. And the only thing that really matters is that you label the sides correctly. You don't have to draw them to scale. I'm not giving you points or taking away points if you don't have them to scale. So this is your angle theta. This is your hypotenuse. Is the vertical side or the horizontal side going to be your adjacent side?
The horizontal.
The horizontal, good. So that's going to have a root 2. Since the hypotenuse in these drawings is always going to be positive, then I have to put the negative here. Now I need to figure out what this side is. And I'm going to use the Pythagorean Theorem, x squared plus y squared equals z squared, or in other words, negative root 2 squared plus y squared equals 2 squared. 2 plus y squared equals 4, y squared equals 2. So y could be a plus or minus square root of 2, but why am I going to choose the positive root? Why would I choose the positive root here? In this quadrant, the y values have to be greater than 0. If I had an angle in the third quadrant or the fourth quadrant, then I would have chosen the negative because you're below the x-axis and the y-coordinate is going to be positive. This is the hard part. And we're done with all the hard part. In fact, it's really easy from this point on. But let me pause here to see if you have some concerns or something around this that I can help you out with. How are we looking right up to here, just drawing the triangle? If there's some confusion, let me know.
Good.
I got one thumbs up. And
The theta you marked, shouldn't it be inside the triangle?
either way,
Okay.
I mean, technically it's here, but yeah, I mean, we're kind of using this as a reference angle.
And Professor, one more thing I learned, I don't know if this can help the class.
Yeah, please do.
Your adjacent is always the one that connects you with between theta and your right angle. So
Okay.
if anyone is having a hard time between picking the adjacent and the opposite, the adjacent is always the one that connects the theta to the right angle. Does
There
that
you go.
make sense?
Connects the theta to the right angle. So here's our
Right.
right angle, and
Yes.
that's going to connect it.
So
Good.
anytime you have a hard time figuring out the adjacent, that's the one.
Actually does help a lot. Thank you.
I had a quick question, Professor.
Yeah, Tim, please.
So, could we do a different problem but with tangent inverse in the middle, where for theta?
Yeah. Let me
So-
finish this one off though. Because
Okay.
we're not done with this one.
All right, I'll wait.
Are you okay with what we've done so far here?
Yeah.
Okay, so let's see here. The big thing here was to draw this triangle. And I hate to be the bearer of the bad news, but the rest is kind of easy. We just need to calculate the secant of that. The secant is the reciprocal of the cosine, right? And since cosine is hypotenuse over adjacent, then secant is going to be, cosine is adjacent over hypotenuse, so secant is going to be its reciprocal, hypotenuse over adjacent. There we go. So it's going to be 2 divided by negative square root of 2, which gives you negative root 2. That's it. So once you draw the triangle, all you need to do is look at your triangle to answer this last question. Comments there? We good on that one? Now, Tim, you asked for one with inverse tangent in the middle, right?
Yeah, specifically like inverse tangent in the middle to -1. I guess what I'm confused about is, I understand that tangent is sine over cosine. So would it just be -1 over 1, and then that's the triangle information?
Well, I guess it depends on what you're given here. I mean, do you have a specific number or example in
Yeah,
mind?
-1.
-1?
Yeah.
Yeah, so what might be helpful in that case is to think of this as the sine of the tangent inverse of -1 over 1, like that. And then we can do the same trick that we did with the last one. And that is, think of that as theta. Now, what this is saying equivalently is that the tangent of theta equals -1 over 1. I mean, technically what it does say is we're letting theta equal tangent inverse of -1. But to go from here to here, what I'm really doing is I'm going to take the tangent on both sides. And when I take the tangent on both sides, I get the tangent of theta. These two things cancel each other out. So I get the tangent of theta equals -1 over 1. Now, Tim's a smart man because he wants to write this as -1 over 1, not just -1. And the reason for that is because he remembers Sohcahtoa, the toa part means this is opposite over adjacent. So that's the ratio of those two sides there, is that tangent. Now, if the tangent is negative, what quadrant should I be drawing this in? Well, the inverse tangent has as its range pretty much the same thing that the inverse sine does. Tangent inverse of
The fourth quadrant.
yeah. Has to be an angle between negative pi over 2 and pi over 2. So yes, it's going to be in the fourth quadrant. And I'll draw a nice little angle here. The
So
opposite.
could you explain a little bit more on why it's in the fourth one? I think that's where the part I struggle the most is understanding.
Sure, great question. It's because of the range of the inverse tangent. So the inverse tangent is going to give me an angle between these two right here. That's the range of the inverse tangent, is that it has to give me an angle between those two. Now, I could draw my triangles in a couple different quadrants, going back to all students take calculus, but I have to draw my angle in a quadrant where the tangent is negative, right? So I really don't have my choice of all four quadrants. So tangent is positive in which quadrants? Well, everything's positive here, and tangent's positive here. So that it eliminates those two. I couldn't draw it in those two if I wanted to. But I can choose between these two. Until you start thinking that, oh, wait a minute. The inverse tangent is going to give me an angle between negative pi over 2 and pi over 2. So the inverse tangent is going to give me an angle between these values, somewhere here or here. I can't draw things in the first quadrant because tangent's positive there. So I have to draw it in the fourth quadrant. Did that help?
A little bit. It's a lot of information to take in, I think.
Yeah, it is. You're being kind. Let's see. So when you're drawing your triangles, let's just kind of do all of them. If you have an inverse sine, you're going to have to choose the first quadrant or the fourth quadrant, depending on if your number here is positive or negative. If you have an inverse cosine, then it's going to be between the first quadrant or the second quadrant, depending on if your number is positive or negative. And that's for the inverse cosine. And then for the inverse tangent, again, it's going to be kind of like the inverse sine. You're either going to be in the first quadrant or the fourth quadrant. And that's because of the restrictions on these inverse functions. I can't just do anything, because if I did, sine wouldn't be a function, or sine inverse wouldn't be a function, cosine inverse, tangent inverse, they wouldn't be functions. I have to restrict it. So depending on if you have a positive or negative value here, you're going to choose the appropriate quadrant. So hopefully that gives you a framework to pick from.
It makes a little bit more sense. Thank you.
All right, good deal. Thank you. Thanks for sticking with me. Now, we drew this in the fourth quadrant because we've got a negative number here. All right, so I chose the fourth quadrant because tangent's negative in the fourth quadrant. Now tangent's going to be opposite over adjacent. Now my sides have length 1 and 1, but one of these has to be the negative one. And in this case, it's got to be the y value. Since we're below the x-axis, the x value is positive. So that's positive there. And from the Pythagorean theorem, you get that this is the square root of 2. this squared plus this squared equals this squared. That's going to be the square root of 2. All right. So this is our angle right there. You can think of it here or here. It doesn't matter to me. But that's our triangle. That's what we wanted. The last thing to do is to figure out what the sine of that angle is. Sine of theta. Sine of theta is what over what?
Opposite over hypotenuse.
Opposite over hypotenuse. So -1 is your opposite side. That side's your hypotenuse. And if you rationalize it, you get -√2 over 2. Let's do one more. I'm not sensing a lot of comfort with this. So before I move on to one more, any other comments or thoughts on this one?
So really, real quick, when you're plugging those numbers into the equation x squared plus y squared equals z squared,
Yes.
those numbers are based off like, you know, your x is 1, and then obviously your y is negative, and then the z squared is your √2.
Yes.
Getting that? Okay.
So if you like, maybe it'd be helpful to see me solve this with the Pythagorean theorem, because I just told you that. But if you do x squared plus y squared equals z squared, it'd be -1, actually it'd be +1, because I was right the first time. 1 squared plus -1 squared equals z squared. 1 plus 1 equals z squared. 2 equals z squared. Plus or minus √2 is going to be z. But the hypotenuse in our drawings is always going to be positive. So choose z equals the positive square root of 2. With your x and y, you got to think about what quadrant you're in, but z is always going to be positive.
Are you gonna raise an eyebrow if we use like different letters like a squared plus b squared equals c
No,
squared?
not at all. Not at all.
Okay.
Thank you. Thank you. Yeah, no, I'm not going to worry about that one bit. So,
I did take Trig back in 2019, and I learned how to do this completely different way. I still have my notes. They're not in my face, so I can't tell you exactly how I learned it. But would it be okay if I use that method or no?
I'm sorry. I mean, maybe it's my connection, but I couldn't understand much of what you said other than that's the way you learned it. Maybe you can try dumping it in the chat, and I
Okay.
can find there. All right. So let's do another one, because I mean, right now these numbers, you can kind of say, well, hey, I can do that on my calculator. Yes, somewhat. I still want to see some work, and I can't be more clear about this. I want to see those triangles drawn. All right, that's going to be part of what I'm looking for when I grade your papers. So let's try and do something that doesn't necessarily work out quite so even. Let's do the cosecant of the sine inverse of 2/7. Not the cosecant. How about the what function? Secant. Let's just do the secant. So sorry about that. This would be the secant of the sine inverse of 2/7. So kind of like some of these other ones, start out by figuring out a triangle. That's your theta. This is the angle. When you take the inverse sine of something like this, you're going to get an angle. And what it's saying to us is the inverse sine of 2/7 is theta. Now what you can do to rearrange that, if you wanted to kind of show your work a little bit more, you don't have to, is you could take the sine of both sides. And the sine and the sine inverse will cancel each other out, and you get 2/7 equals sine of theta. For my money, and for what I'll be looking for on the exam, I would just suggest you just dump right here. This equals this is the same as this. Don't bother showing me that, okay? Now, what does this help me do? This helps me draw my triangle. What quadrant am I going to draw that triangle in? Maybe you guys should take a screenshot of this, right?
One.
Yeah. Has to be in the first or fourth quadrant if you're dealing with the sine inverse. And because you're dealing with a positive value, it's going to be in the fourth quadrant or the first quadrant. So quadrant 1. And don't worry about trying to draw it to scale. The important thing is to get the sides correct. So that's my theta. Now think back to 2/7 or sine of theta. Sine is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So
Opposite over hypotenuse.
there you go. Opposite over hypotenuse. So that's going to be a 2. That's going to be a 7. We need to figure out what x is. So it's going to be x squared plus 2 squared equals 7 squared. X squared plus 4 equals 49. X squared equals 45. X equals plus or minus a square root of 45. Do I want the positive root or the negative root?
Positive.
Positive.
Positive, because you're in the first quadrant. X is positive here. So x is the square root of 45. So I've got the secant of the sine inverse of 2/7. That's the same as the secant of theta. Secant is a reciprocal of the cosine. Cosine is adjacent over hypotenuse. So what's the secant going to be?
Seven over root 45.
Good. It's going to be a hypotenuse over the adjacents, which is going to be 7 over square root of 45. You might have to rationalize that. 7 square root of 45 over 45. I think it'll probably accept that. I will. But there you go. All right.
Professor,
Yes.
are you
Great.
posting this video on YouTube?
Yes.
Perfect.
I post them all
Before
on
the exam,
YouTube.
right?
What's that?
Before the exam?
Yes. I will try and get it up there tonight.
Thank you.
Any other follow-up questions? All right.
I just want to make sure, but the reason why it's in the first quadrant is because it's a positive 2/7, right?
The reason why it's yes, yeah, it's a positive 2/7. So
So if it was a negative 2/7, it'd be in the fourth.
exactly. If it was a negative 2/7, it'd be in the fourth. Yep.
Okay.
Perfect. So depending on whether or not the argument of your inverse function is negative or positive, that's going to determine what quadrant you pick.
Okay. And then the sine, cosine, tangent decides which sides it's on.
Yeah, so, you know, positive or negative is going to determine, yeah, your choice between the two. And sine, cosine, and tangent, you know, also determines what quadrant a little bit. It narrows it down to 2 quadrants. Notice you never, ever have anything in the 3rd quadrant, right? You can have something in the 1st or 4th quadrant, the 1st or 2nd quadrant, but never the 3rd quadrant. You should not be drawing 3rd quadrant angles for any of these things.
Okay, I'm starting to get it. Thank you.
Excellent. I appreciate your help there, Zach. All right, is there anything else? All right, let me get you in your breakout rooms.